Our today's lesson is the slope condition for parallel lines in coordinate planes. Recall from the lesson on parallel lines that parallel lines are two or more lines that lie in the same plane but never intersect. For example, we have these in the same plane but they never have an intersection. In the coordinate plane, lines that are parallel share the same slope and have different y-intercepts. So, for example, we have y equals mx plus b. If another line was parallel to that, you have y equals mx plus, and let's say b1, to be a different y-intercept. But the slopes have to be the same. That's what you're looking for. And these must be different. If the y-intercepts aren't different, that means that line would overlap and it'll be the same line. But if it has a different y-intercept, that means it's going to cross the y-intercept further up. But the slope ensures that it doesn't touch. Without graphing, which pair of equations are parallel? Is it A, B, or C? Well, if you look at it carefully, you would see that it has to be C because it has the same slope of 4 but different y-intercepts. Without graphing, which pair of equations represents parallel lines? Well, now be careful. Sometimes you have to put it in slope-intercept form. So it can't be A. You have y equals x, x equals y. Those are two different slopes. B, you have y equals 2x minus 5 and y equals negative 2x. Well, negative means it's a different slope. But this one is not in slope-intercept form. How would you know? So I'm going to take 3x minus y equals 2, and I'm going to put it in slope-intercept form. And that's just simply moving the x term to the opposite side and isolating the y variable. Let's try that. So you can get negative y equals negative 3x plus 2. And if I multiply or divide by negative 1, I just switch the signs. So I get y equals 3x minus 2. Similarly up here, I had 6x minus 2y equals negative 2. If I move the x term to the other side, I get negative 2y equals negative 6x minus 2. If I divide everything by negative 2, I get y equals 3x plus 1. And that satisfies the requirement for it to be parallel. I have the same slope, but I have different y-intercepts. I have a y-intercept of negative 2 and positive 1. Therefore, C is the answer for the two lines being parallel. This concludes the lesson for today.